Hello everyone, today we are going to be going over the blind 75 in C++, and today we are working with the problem invert/flip binary tree. So, to be able to give a breakdown on the problem, make sure that we've always have our 4 questions already set in place to fully understand the problem. We need to ask ourselves what the input's going to be, what data structure/algorithm/technique to use, what to do with the data, and then what our output is going to be, or we can just put in the output. So now, just to be able to break down on the problem, given the root of a binary tree, invert the tree and return the root. Okay, so pretty self-explanatory of what we have. So we are given the root of the binary tree. What we need to do for our output is return the root of the flipped binary tree. And the technique we're going to be using for this is depth first search accordingly. And what we would need to do for our following steps would be the following. 1. Need to initialize our root in the case of when it's null. We need to swap both the left and right children of the root from the current tree. And we're going to recursively call the function for the left child, since we will be calling upon from the tree structure right over here for left and for right, and that we can have a node in particular within our parameter. So whenever we are making a recursive call, we will be calling upon this function for the left, and then we'll also do the same for the right. Finally, return the root. And it should look something like this. So step 1, we're going to be putting in the edge case where the root is null. Return null enter. Then we're going to swap both the root for the left and the right. Alright, step 3 and 4, where we will be doing a recursive call, tree, where we would have the root for being the left, and do the same for the right, accordingly, and then finally we're going to have our output. It's pretty easy, very self-explanatory right over here. Let's just make sure everything's already correct, so that way. Alright, it passes all the test cases. Let me just clean this up for you folks so you folks can be able to thoroughly see the whole solution accordingly. These are notes that we have. Here's our output. Yeah. Submit this. Alright, and it's complete. So to be able to give a breakdown of our space and time complexity for the following is that our time complexity is going to be O of n, where n is the number of nodes in the tree, given the fact that we are visiting each node at least once to invert the tree, and then the space complexity, given the fact we're using depth first search, the space complexity is going to be O of h, where h is the height of the tree. And the reason being is because the following space complexity is using depth first search to be calling upon a stack during the recursion process for when we are calling upon our function invert tree to be able to flip every single node accordingly from the left to the right. So yes, this was invert binary tree. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.